The hunter-gatherers of southern Africa around 100,000 BC represent one of the earliest branching distinct human groups, and they emerged as a genetically and culturally distinct population deep in the Middle Stone Age. Recent genetic studies confirm that southern African Khoisan people have some of the most divergent lineages of all living humans. This 2020 analysis of Khoisan genomes found about 25% of the DNA variants were unique to them, and that overall they carry the highest genetic diversity in the world. This diversity marks them as an ancient lineage, one that split off early from other Homo sapiens. And like the founder effect mentioned in last week's video, to put it simply, as each group goes out, that's only a subset of the original group, and the further and further you migrate away, the less and less genetic diversity you should find. And that's exactly what we do find with populations across the Earth, with the people of the Amazon and South America having the least genetic diversity, and Africa having the most. A memorable way it's often put is that two people from anywhere in Eurasia are far more genetically similar to a pair of randomly chosen Africans. The latest research suggests that modern Homo sapiens did not arise from a single cradle or Eden, but rather from interconnected populations across Africa. Quote, at different times, people who embrace the classic model of a single origin for Homo sapiens suggest that humans first emerged in either East or Southern Africa, notes geneticist Brenna Hen. But fossil and archaeological evidence shows Homo sapiens living across the continent by 300,000 years ago. Instead of one founding tribe, humans in Africa were diverse and dispersed, mixing over hundreds of thousands of years, a time frame that really just is hard for us to grasp. When we're blown away by how ancient the pyramids are at around 4,500 years, and Göbekli Tepe being more than double that at 10,000 years. It's crazy to think we've been anatomically modern humans for around 300,000 years. But eventually, after all this mixing, we can start to identify some of the earliest distinct populations that emerge, and the southern African hunter-gatherers stand out. According to a 2023 genomic study published in Nature, the earliest major population split among central humans occurred roughly around 120,000 to 135,000 years ago, giving rise to an ancestral Khoisan group living in southern Africa. In other words, by around 100,000 years ago, our southern African ancestors were already a distinct branch, separated, though never completely isolated from other human groups. And there is some genetic modeling that indicates another demographic merger around 100,000 years ago, involving populations from Eastern and Western Africa, a lineage that would later include people who left Africa. And so all of this paints the picture of multiple human lineages in Africa exchanging genes and ideas. Rather than evolving in both genetic and cultural isolation, the ancient San ancestors likely interacted at times with neighboring groups, and gene flow back and forth, quote, provided a much better explanation of the genetic variation we see today than any strict single-origin model, explains population geneticist Simon Gravel. It appears that weakly separated early Homo sapien populations, what are called stem groups, like the central part of a plant that will then branch out, these existed across Africa and kept in contact. Over many generations, one of these networks in the south crystallized into what we know as the Khoisan lineage, carrying subtle genetic differences that set them apart. We should note that researchers infer that only a tiny fraction, perhaps 1 to 4%, of the genetic differences among people today could be attributed to the drift between those early African populations. The rest is all shared heritage. And remember, that's often worded very confusingly. That is only 1 to 4% of the 0.01% difference. In other words, it's only 0.0004% of your total genome difference. Because we are all 99.9% the same. We're almost 99% the same with chimps. A lot of people think that means it's a whole 4% genome difference, which would mean you would be more different than us and orangutans. So we call them distinct people groups because there is this tiny genetic difference that we can detect, but it should be stressed just how tiny that is. And since we are 99.9% the same, this means that fossils from around 100,000 years ago in different parts of African regions would all look alike despite belonging to separate groups. So in short, the ancestral San were part of the root stock of Homo sapiens, branching off early, yet still connected via occasional migrations and mingling with other Africans, rather than an isolated offshoot. And their genetic legacy is profound. The Khoisan today retain lineages that stretch directly back to these deep prehistory populations, making them invaluable for understanding human origins. And we need to understand that around 100,000 years ago, the world was heading into a glacial phase. Global sea levels were a bit lower than today, though not as low as 20,000 years ago. And so there were expanding coastal plains. Meanwhile, temperatures in southern Africa were likely a few degrees cooler on average, and rainfall patterns shifted. Pollen and isotopic studies in the region suggest that parts of the MIS-5 oscillated between warmer and moister climates and cooler, drier spells. One record from a South African lake shows that around 100 to 90,000 years ago, the climate became increasingly variable, with some dry intervals leading to more shrubland vegetation, and cooler periods reducing tropical plant types. But humans proved adaptable, moving as needed to favorable niches. They could take refuge in the coast during arid times and spread into the interior when rains returned. This flexibility in exploiting both coastal and inland environments would have been crucial to their survival and success. And by occupying diverse zones like seashores, grasslands, wetlands, and the desert fringe, the ancient San ancestors developed different adaptations. Groups living in the arid interior may have evolved a smaller body stature and efficient fat storage to cope with the hot days, cold nights, and unpredictable food supply. San people today are some of the shortest people on Earth, and their women are historically known for concentrating fat deposits around their waist and thighs, which is thought to be an adaptation for energy storage in tough environments. And San men average around 155 centimeters or 5 feet 1 inch, and weigh around 50 kilograms or 110 pounds. While the women average about 145 centimeters or 4 feet 9 inches and weigh around 43 kilograms or 95 pounds, making them one of the shortest and leanest populations in the world, adapted to their traditional foraging lifestyle in these arid regions. The coastal groups, meanwhile, might have had more constant food but had to adapt to marine foraging and maybe even swimming and diving for shellfish. And so these regional differences led to variations in culture and toolkits, even among populations that were closely related. Archaeologists have found abundant food remains in coastal caves from this era, especially shell middens piled with marine mollusk shells. At sites like Klassi's River and Blombos Cave on the southern African coast, layer upon layer of shellfish, like limpets, mussels, and periwinkles, and tons of fish bones, are proof that early humans harvested the sea regularly. This marine menu was nutrient-rich and a more predictable food source, and some researchers believe it triggered a shift from, quote, living in highly mobile bands of hunter-gatherers to more sedentary communities. In other words, the coast provided a stable buffet that may have tethered people to one area for longer periods, far longer than their nomad cousins ever managed. Quote, when hunter-gatherers expanded their diet to include coastal resources, they ended up having characteristics unique among hunter-gatherers, says archaeologist Curtis Marine. Marine's excavations along the Cape's southern coast show that these shellfish-rich locales supported larger and more permanent groups. People didn't need to roam as far or as often because these tidal areas reliably refilled themselves. With more food on hand, populations grew. Territories became more valuable and defended, and technology advanced to manage conflicts and new hunting challenges. That's one of the simplest rules that every people group will follow from here on out, that once you settle down in one place and have your caloric needs met, you'll start increasing your tech pretty soon. Marine argues that projectile weapons like the bow and arrow or spear throwing may have emerged in this context, as groups had to defend territory or hunt more efficiently to feed a settled community. And we do see that some of the earliest evidence of bow and arrow technology comes from South Africa. Tiny stone points from Sabudu Cave, around 64,000 years old, are believed to be arrowheads, and a bone point from around 61,000 years ago also points to bow hunting. It's simple to say this was just for hunting land mammals, but it is interesting that it is popping up with these people getting calories more from the sea, and that might seem like an unlikely place for bow hunting, but their point is also that it's for keeping other people away from this area. Bows and arrows as a defensive weapon. But even if it is just for hunting, some of the earliest photos we have of the Andaman people, who are living a very similar lifestyle, were hunting turtles and fish with their bows. And so all of this suggests that by relatively not long after 100,000 BCE, southern African humans were innovating new weaponry, possibly spurred by the social pressures of a semi-sedentary life. Moving inland, their diet was different but no less varied. The ancestors of the San were consummate foragers. Men hunted medium to large game, and women gathered food plants, a division of labor that dates back to this deep past. Stone tools and animal bones from open-air sites and cave shelters show a broad spectrum of hunting strategy. They hunted antelope of all sizes, from agile springboks to hefty kudu and wildebeests, and occasionally larger prey like giraffe or juvenile elephants. Animal bones often have cut marks from stone knives and signs of being broken from arrow. Researchers studying late Pleistocene sites in southern Africa find evidence that people employed opportunistic but effective hunting tactics, like trapping animals in ambushes, using fire to drive game, or persistence hunting, which is something humans are excellent at. We don't have all the flashy weapons and armor of most other animals, but we're one of the best at chasing prey until they overheat. Along with meat, fat, and marrow were critical calories, essential in colder and drier periods where plant foods died off. And though plants waned, they were still a year-round staple. Archaeological hearths contained charred bits of wild tubers and roots, showing that they were roasted for eating, and the border cave rhizomes show that around 100,000 years ago, people deliberately dug up and cooked starchy roots, likely sharing them among the group. This is what's dubbed the African potato, and it was a reliable carbohydrate source that would have been especially important in these inland areas, where they experienced seasonal shortages. And what about their cultural life beyond just eating and hunting? Though the material remains are sparse, southern Africa has some of the earliest evidence of symbolic thought and artistic expression by humans. In Blombos Cave, archaeologists uncovered pieces of red ochre engraved with cross-hatch designs in geometric patterns, which are dated to around 100,000 to 75,000 years ago. They're essentially using them like crayons, just this solid stick of iron-rich pigment, and it shows that they have some sort of aesthetic sense, whether it's just some art to entertain themselves, or if it represented some abstract motif, something that was meaningful to the clan. Blombos also had shell beads, these tiny perforated shells around 75,000 years old, and is thought to be the world's oldest jewelry. These are Nassarius snail shells, and they seem to have been strung on a cord or sewn into clothing as ornaments. It could have been some of the earliest social signaling, either status or group identity or some specialization, or just simply as jewelry because it looked good. I've talked before about hominin artwork from the carved shell of Homo erectus around 500,000 years ago, and so while these sites from around 100 to 75,000 years ago are not the oldest, this is a Homo sapiens site that is older than the famed Neanderthal caves of Europe and the Denisovan jewelry, which are both dated from around 70 to 40,000 years ago. Now with this stuff, I personally find it fascinating how morphic field theories do map onto these archaeological finds and broader studies of civilization, as it's so odd that we have the same biology of modern Homo sapiens for around 300,000 years, and then when things pop up in one place, they also quickly pop up in a ton of other places. And you might just think they're in contact with each other, but that does break down for later aspects of civilization, like domestication events and megalith projects, that do have these huge jumps all around the same time, even when we have no reason to believe that these people were in direct contact with each other. I'm just throwing that in there. Mainstream science doesn't think much of this theory, but to be fair, they don't really look into it either. I have a whole video written on that, so I hope to make it soon. Basically, it's the whole idea that how species are able to learn traits, things that become what we call instinct, and seem to do so even when separated under lab conditions. Maybe this is happening with humanity too, as it's some sort of shared consciousness amongst a species. But don't worry, back to the Khoisan. Besides art, they likely had rituals and beliefs along with this, though this can only be inferred indirectly. The practice of burying the dead pops up at this time, and while not much is known about their burial customs, Africa's oldest known deliberate burial, a child interred in a cave in Kenya, is dated to around 78,000 years ago, and shows that humans by this time cared for their dead and likely had spiritual concepts of death, likely some concept of life after death. While in southern Africa, we have the border cave infant around 78,000 years ago.
The child was buried in a fetal position, and the child was adorned with shells which came from some 60 or 100 kilometers away.
Again, around the same time, we're seeing this with Neanderthals too. And it really is part of why the entire Homo genus is considered human. Because at least since Erectus, they're all doing this stuff we think is unique to humans. I'd push that it's just unique to intelligence, as there's the famous case with the mourning elephants too. And it's believed that these hunter-gatherers had a rich oral culture, telling stories around campfires and teaching survival knowledge through generations. By studying living San people today, and some of the most ancient cultures all over the world, it's believed that they had what's called a trance dance, and shamanic healing rituals going this far back in time.
Ta masuhana ta kume mnom ko shin kan yito ta kume neske ha hasa usana ta ko shin kan kwata ko ha kan ka ta ko kan ka ko kan ya kuri ha ta haja shin kan ko ha ko kuru ha ko de neske ko ha ba ta ko man kan ya ko ne ko akar ko sumala ko na ko ya ko na ko ya ko na ko ya ko ako kabar ko ting na ko ta ya ta ta ka ra ba ko tsi ka ute ka ba im trim khwara khata te ko ngai ka uta chi te som ko khare mo ko chi ka ma chi te hata ma ka ban ko anu ke a hata mam ko kuri te ka hata ha tsi sa ba ma te cha ute ne pe mo ate ne pe khor ko ka ma sa khute de ka ko ka ma te ka usma me khaba anja mo ham ka ba ma em ko ba na te ko kana em to ba na ko ngai ka hui ton ko se ke em to ba mi mo na guite mis nas kama masa guite skone rakata kai wa ita khata mo doaka tei do e sakai ne ko te karu no kom na ta iko me ase ta si nta ko no ko si akute ya khaja kai sir ko no kar ngata ma si man no an erne kar ko kam ko nas ka khata si man no ta ba gabi sabat anja si hana ngan ko kam kamar ko kai ko te kam no hore sir ko te khata kam no kammer ko kam ka tsair ko khatar ko ore sia ko no ke mas ka kham nari banga khata ko kam ho ha ko mate kam ha mo ate ko kam ma dul ko kule sar uwa khaba ba nari ba mate ha ama se nar bunga kama chikaure jar ko mo chika bunga ka sana ka thana ti ko.
Rock paintings occur much later in the Holocene, depicting dancing figures and shamans. And so while we can't date those 100,000 years back with certainty, because so many other aspects have stayed the same, the roots of San's spiritual life, centered on the eland, the trance healer, and the realm of spirits, likely also was part of these people's worldview. Technologically, the toolkit of 100,000 BCE hunter-gatherers was part of the Middle Stone Age tradition. They made stone tools that were more refined than the crude hand axes of earlier eras, and a common technology was the levelwa technique, preparing stone cores to strike off sharp flakes and points. And by this time in southern Africa, people were producing stone spearheads, which could be hafted onto wooden shafts, and possibly lighter points for darts or arrows. Two well-known subcultures slightly after 100,000 years ago are in Still Bay, of 75 to 70 years before present, and Khoisan's Port, around 65 to 59,000 years ago. Still Bay tools are beautifully shaped lanceolate points, probably early spearheads. Khoisan's port tools include tiny backed blades, called microliths, that some think were for hafting onto arrows or complex tools, used for chopping and processing food or crafting other objects. These industries show an inventive leap, but sadly and most interesting is that some of these traits don't persist, suggesting a boom and bust of innovation even back in the Middle Stone Age. It's as if these ancient communities had periods of cultural flourishing, possibly linked to stable climate or larger populations, and this was followed by fragmentation, something that will also prove to be common for the rest of human history. Maybe time-traveling Mongols got them. The ebb and flow of tool styles across sites points to the fact that different groups sometimes develop their own styles, but then later may have exchanged techniques. Because like we see with the rock shelter excavations across South Africa, it shows that not all groups adopted the coastal sedentary pattern. Some remained highly mobile inland hunters, and so we see a wide variety of styles, even if they are genetically distinct enough to be their own group. Coastal, semi-settled bands hauling in shellfish and crafting bone awls and beads, and nomadic inland bands trekking between seasonal waterholes, carrying mobile toolkits of stone and perhaps digging sticks. Yet they're all part of a broader San ancestral culture, sharing core features like egalitarian social structure, reliance on both hunting and gathering, and the use of ochre pigments, and an intimate knowledge of nature. Now I want to turn to their interactions with others, so let's understand the state of humanity at this time. There are Neanderthals throughout mostly Europe and into Asia, but Denisovan is throughout most of Asia. The earliest migrations of Homo sapiens out of Africa were far more complex and staggered than once thought, with multiple waves coming before that single successful expansion that was the source of all the non-African populations today. One of the most groundbreaking discoveries in recent years was at Mislia Cave in Israel, where a modern human upper jawbone dated to around 180,000 years ago was found. This fossil is currently the oldest known Homo sapien remain outside of Africa, pushing back the timeline of early dispersals by nearly 50,000 years. It shows that modern humans began exploring beyond Africa much earlier than previously assumed. And it's not just this discovery. Other early human remains were found at Skull and Kafsa caves in the Levant, dating to around 120,000 to 90,000 years ago. These individuals possessed a mix of archaic and modern traits and are associated with Middle Paleolithic stone tools. They likely thrived during a warm, interglacial period when the Levant was lush and green, but these populations appeared to have eventually gone extinct, replaced by Neanderthals during later glacial phases, or they just retreated back into Africa. Evidence from the Arabian Peninsula also supports the idea of these early migrations. Sites from Jebel Faya, Dhofar, and Al Wusta, where a human finger bone dating to around 85,000 years ago was discovered. It all shows that Homo sapiens moved into what was a green, habitable Arabia, simply caused by an increase in rainfall. But like the Levantine populations, these early settlers seem to have either died out or were such a small group that they don't leave any lasting genetic impact. The only migration that clearly succeeded in permanently establishing Homo sapiens across the world occurred around 70 to 60,000 years ago. This group likely left from East Africa, crossing the Bab el-Mandeb Strait into Arabia, which is also where experts think Homo erectus may have crossed over 1 million years earlier. But this allowed for a southern coastal route through South Asia, Southeast Asia, and into Australia. This expansion was rapid and decisive, forming the founding population of all modern non-Africans. Genetic studies show that this group may have only been a few thousand people, who then spread and diversified. And along the way, they encountered and interbred with Neanderthals in the Levant and Europe, and with Denisovans in parts of Asia. And so while there were multiple early excursions out of Africa, beginning at least as early as 180,000 years ago, only one wave beginning around 70,000 years ago left descendants who survive today. And so this means that around 100,000 years ago, the southern African hunter-gatherers were inhabiting a world where other Homo sapiens were still just in Africa. Populations in East, Central, and perhaps North Africa, as well as a few archaic human groups might have still lingered. In southern Africa itself, there is intriguing evidence that other Homo species occupied the landscape in earlier times. Homo naledi in the Transvaal up to 250,000 years ago, and possibly late surviving Homo or Homo-like populations hinted at fossils like the Florisbad skull, dated to around 260,000 years ago. Though it is believed that at this time it was just anatomically modern humans here. Though they were not monolithic, the genetic evidence shows us that they had regional clusters, like the San ancestors in the south, rainforest hunter-gatherers in Central Asia, etc., and though they were homogeneous enough to tell them apart, we can also tell that they occasionally met and mingled. One major question has been whether African humans ever interbred with non-sapien lineages, like what happened in Eurasia with Neanderthals and Denisovans. Some genetic studies of West and Central Africans have suggested traces of what's called the mysterious ghost archaic lineage, but in southern Africa, there's no strong evidence of Neanderthal or Denisovan-like input in this deep past. A recent Nature study argues that what appeared to be archaic DNA can be explained by long-separated modern lineages who were interbreeding much later on. In essence, the southern group, the San ancestors, and other groups like ancestral East and West Africans had been diverging for many millennia and might have been growing so distinct that their eventual mixing could create the illusion of archaic ancestry. So rather than encountering an outside species, the San's forebearers likely interacted with other Homo sapien groups that had slightly different genetic makeups due to their geographic separation. Though, of course, this is all still very new and very complex, and it's all heavily debated. I just want to share the most up-to-date info, taking us to the real cutting edge of what we know about these people. But within Africa, contact could occur via gradual range expansions. Climate improvements might have opened corridors through semi-arid areas, allowing southern Africans to move north and meet populations from East Africa coming south. and genetic evidence hints at a south to east gene flow, at least at one point in history. One model suggests a dispersion from southern to eastern Africa around 70,000 years ago, just before the main out-of-Africa migration. This could mean that certain cultural innovations, like advanced stone tool technologies or symbolic practices, originated in southern Africa and spread northward, possibly sparking the population boom that led to humans expanding beyond Africa. Archaeologically, we see that some South African tool styles, like the Stilbay and Khoisan's port mentioned before, they were mostly local. But soon after, around 60 to 50,000 years ago, a more uniform, so-called later Stone Age appears all across Africa, as if these ideas somehow were diffused across all these people groups. The ancestors of the San might have been innovators and teachers, contributing to the toolkits and behaviors of other groups they encountered. As for incoming groups, around 100,000 years ago, there were likely none entering South Africa yet. Modern humans themselves had not fully left the continent, and distant Neanderthals and Denisovans remained in Eurasia. It would be tens of thousands of years later that outside lineages returned, like the pastoralist from East Africa bringing livestock around 2,000 years ago, or even Eurasian gene flow in the past 1,500 years due to the Indian Ocean trade. Those developments are far in the future relative to 100,000 BCE, and likely a decade away for this channel. At the time in question, any incoming group would have been other African Homo sapiens migrating due to those environmental shifts. Something like a prolonged drought in East Africa sending a group of foragers roaming farther south, where they eventually encounter communities of the San's ancestors. They could exchange mates, explaining that gene flow, share tools and stories, all around a shared campfire. Over these encounters, the genetic distinctions blurred at the edges, but overall, each region retained its core identity, and this is exactly what geneticists observe. A reticulated or net-like population history, rather than neatly separated branches. Southern Africans contributed to the genetic makeup of all humankind. Some of their descendants likely joined early migrations that seeded Asia and beyond, and in turn, they absorbed some genes from other African lineages that passed through. There's even one study of ancient DNA from later periods that shows a continuity to today. 3 Stone Age hunter-gatherers from South Africa, dated to around 2300 to 1800 years ago, were genetically related to today's Khoisan people. But long before that farming influx, the late Pleistocene San groups likely had the subcontinent to themselves for tens of thousands of years. And it's believed that around 100,000 years ago, the distinctive click-based languages, like those the San speak today, were already forming, further distinguishing these people groups from each other. Linguists consider the San to be among the most ancient languages in the world, and though of course we can't directly prove that they're 100,000 years old, because we know that humans and even other Homo groups are doing such complex, group-based tasks, it is very likely that they were using some sort of language. And so at least the precursor to this language, some sort of simple click consonants were being used. And a bit of speculation, but it's interesting that some of our oldest languages also don't have vowels, from the Egyptian to Semitic languages. Fast forward to today, and the San people of Botswana, Namibia, Angola, and South Africa continue the legacy of those ancient hunter-gatherers. Everything from their genes to their tech and their language are believed to be some of, if not the oldest on Earth. But what's really interesting is that their language is also one of the most complex systems. It's different linguistic systems often grouped under the controversial term Khoisan, and they are not a single family but rather a grouping of several distinct linguistic lineages, most of which are endangered or nearly extinct. These clicks are not found in most languages worldwide and are categorized into several types. Dental, which is written as an I or a line, which sounds like a sharp tisk-tisk noise that you might use in disapproval. Lateral, which is 2 lines, similar to the sound used to urge a horse forward, like ya. Alveolar, which is an exclamation point, is a loud popping sound made with the tongue against the roof of the mouth. Palatal, which is this long sideways H thing, a softer sound produced when the tongue pressed flat against the hard palate. And the rare labial, which is this little circle with a dot, made with the lips popping like a kiss. Each of these can be further modified, vocalized, nasalized, aspirated, glottalized, producing over 80 to 100 distinct click consonants, compared to only about 24 consonants in English. And they're not only rich in consonant sounds, but also in the use of tone and complex grammatical structures. Tone refers to using pitch, high, medium, or low to distinguish meaning between words, similar to how Chinese works, not implying that these languages are related in any way. And grammatically, many San languages follow word orders different from English. While English follows subject, verb, object, like I eat meat, San languages often use subject, object, verb, I meat eat, or verb, subject, object, eat, I meat. This is seen in many other languages. Many of them are also agglutinative, meaning words are built by stringing together many smaller parts, each with its own meaning, much like in Turkish or Japanese. Some San languages also include noun class systems that distinguish gender, like masculine, feminine, or neutral, done with suffixes or tonal changes. Linguists often group San languages into three main families, though the relationships are debated. The K'ta family includes K'ng, spoken in northern Namibia, Angola, and Botswana, and it features more than 80 consonants and 5 click types. That's over 3 times the number of consonants found in English. The Tu family includes Ta, found in southern Botswana and northern South Africa. Ta is often called the most complex language in the world, with over 140 consonants, more than 80 different click sounds, and over 20 vowel types that differ in length, tone, and nasality. Then there's the Khoi Kwadi family, which includes Nama, the most widely spoken Khoisan language, with about 200,000 speakers today. Nama has a simpler grammar and fewer clicks, likely because of historical contact with Bantu-speaking neighbors. These languages are not just fascinating because of their unique sound systems, but they also reflect the spiritual and cultural lives of the San people, as the clicks are often heard in songs, chants, and healing rituals, and are used to imitate animals, birds, and natural elements. Traditional healers may enter altered states of consciousness, and the specific click sounds used in chants can carry spiritual or symbolic meanings. Many of their words are onomatopoeic, which means that they're mimicking the sound of the environment. You might have heard that the Egyptian word for cat is mew. That's when things are named for just how they sound. But this is done on a much broader scale in San languages, and is great evidence that the earliest form of language was just people mimicking the sound so that the person you're talking to knew what you were thinking about. Likely pantomiming or acting out with your hands what you want them to do, combined with the sound of a thing. Like you can act out throwing a spear and make the sound that a zebra might make, so the other people know you're saying, "Let's go hunt zebra." Because they're one of the oldest genetic lineages, and this language is both so primitive in one sense, and that we could tell it's obviously developed out of directly living in nature, mimicking the sounds of nature itself, but has gotten so incredibly complex over time, everything points to this being one of the earliest spoken languages on Earth. And it's believed that several Bantu languages, like Zulu and Xhosa, adopted their clicks from the San languages. Experts like Tom Goldman, a linguist specializing in African languages, does warn that just because we're hearing this spoken from the same people that are direct ancestors of those people, we should be cautious to think that we are hearing exactly what it sounded like 100,000 years ago, as the influence of neighboring tribes in just so much time means that while of course it's an invaluable language, like any other living piece of culture, it too likely changed over all this time.
It's called by the English-speaking people the click song, because they cannot say uqongqothwane.
And many of these languages are critically endangered. Those like Amkwe have less than 10 fluent speakers, and even Ta, despite its global linguistic fame, is spoken only by a few thousand people, and they're all mostly elders. It's a combination of colonialism, apartheid, displacement, and language stigma that caused widespread language shift to more dominant regional tongues like Tswana, Afrikaans, and English. In many communities, the young San people no longer see any reason to learn this very complicated language spoken by their grandparents. But as to the broader story about why a potential group from these people eventually migrated out and would come to dominate the entire globe, we don't know exactly what that pressure was. Was it just a want to explore? Were they pushed out from kind of intertribal war? Or was it some environmental factor? Whatever it was, experts like Marine hypothesize that the intense cooperation seen in modern humans may have been the most strengthened in those South African coastal refuges. In realizing they had found a good spot together to defend it and use these natural resources in new ways, these high levels of cooperation could have saved our species during crisis events like the massive Mount Toba volcanic eruption around 74,000 years ago. If a few hundred humans survived by banding together along South African shores, they could have grown into those few thousand that eventually did make it out of Africa That successful emigration that would see them become the common ancestors to all living people today. It should be stressed that they're not saying that all modern humans trace them back to that single coastal refuge. While we all share Y Adam and mitochondrial Eve as our descendants, they are at least 130,000 years into what we think are modern humans. Our species was shaped by the entirety of Africa, and those two descendants that we all share could have been mixed with all sorts of people groups throughout Africa, and many different groups could have taken this migration route out. Still not an incredibly high number. Experts do still think it was just around a couple thousand people, but that doesn't necessarily mean they all came from a single tribe. Though in general, it is likely to say that they look something like the San people, as they have relatively lighter skin, eyes that are often associated with Asians, and are one of the most diverse lineages in all of Africa. Of course, there's a million little nuggets of nuance, but the modern-day San people give us the greatest look at how our shared ancestors lived around 100,000 years ago. Thanks for watching. I'll see you in the next one.